Welcome. This video shows how tools from APPS can be used to support the cognitive human-robot interaction in SMEs. We are going to explore the capabilities of two tools, FAMS and IM, both developed by SUPSI. Within Better Factory, the C-HRI Scenario aims at providing tools for monitoring some human parameters, so that to suggest interventions to improve the overall worker's well-being. From literature, we know that a better well-being leads to lower stress levels, improving the worker's performance in turn. 4 different tools are available in Better Factory to support the scenario. The sensing layer, SL, and the pose recognition and correction, PRIC, are in charge of collecting data from sensors and cameras. SL exploits wearable devices to collect physiological data like the heart rate, while PRIC exploits 3D cameras to detect the current worker's pose. Physiological data are read by the Fatigue Monitoring System, FAMS, which is capable of estimating the level of exertion perceived by workers. The predicted values, together with the poses recognized by PRIC, are read by the Intervention Manager, IM, to suggest rule-based interventions, given the actual worker's conditions. Here we can see the C-HRI scenario at a glance. Different tools are exchanging data by means of the Orion Context Broker, which maintains up-to-date the current status of factory entities. In such a way, FAMS and IM can read the most recent workers' conditions as soon as they're sent to the broker by SL and PRIC. Let's see more in details how FAMS and IM work. The FAMS estimates the exertion level of workers using a machine learning model. To feed the model, 2 different kinds of data are needed, static data and dynamic data. As static data, we mean human features that are static over time and do not change frequently, like the age or the weight. Instead, parameters changing at high frequency are referred to as dynamic data. Examples of dynamic data include the heart rate and the skin temperature. From the architectural point of view, we have a single module monitoring changes about dynamic and static data. We know that dynamic data are published on the broker. Concerning static data, they're collected by means of a Google form, then stored in a private database available to FAMS. FAMS queries data at a given rate, like every 5 minutes, and it publishes a new prediction for each available worker to the broker. The IM aims at improving humans' interactions with the surrounding environment, as well as humans' well-being. The goal is achieved by suggesting interventions to operators, based on their conditions. The decision logic is encoded in rules that are triggered when certain conditions are met. For example, a worker may be suggested to have a break if her current perceived exertion level is greater than 6. IM rules are based on data from FAMS and PRIC, thus workers' perceived exertion and pose. By looking at IM architecture, we observe that IM reads the inputs directly from the broker and send back to the broker the suggested interventions. Differently from FAMS, that is a back-end service, IM has a proper user interface to define the intervention rules. We will see in a moment how to define intervention rules in IM. This figure depicts the overall architecture of FAMS, IM, and their satellite components. Worker Data Importer and Kafka Bridge are 2 extra components required to integrate FAMS and IM with the cognitive HRI scenario. The Worker Data Importer is the tool in charge of storing worker static data in the database accessed by FAMS, while Kafka Bridge is a tool to convert FAMS and IM outputs into NGS entities, so that to adhere to the Orion broker specifications. To set up the working environment, we need to have Docker and Docker Compose installed in our machine. We tested our tools by using the Docker and Docker Compose versions you can see specified here. Given that all the tools we provide are already Docker images, we don't need any other requirements. The whole deployment is handled by Docker Compose. The GitHub repositories already comes with Compose files importing the required set of Docker images. Let's see how to deploy FAMS and IM using Docker Compose. At the end of the procedure, we will have the Docker container deployed on our machine, interacting each other as depicted in this figure. First of all, we have to download the RAMP repository available in GitHub. We already downloaded it to speed up the demo. We report the link here for your convenience. Then, we start deploying FAMS and the full set of satellite components, also needed by IM. We have to remember this point later so that to avoid errors with Docker Compose. Here we just need to issue the compose up command. Now, we deploy the IAM. Since satellite components are already there, we have to issue the compose up command with an additional option, so that to avoid redeploying the same components twice. We now have FAMS and IAM up and running. However, data produced by these tools are not stored in Orion. To achieve so, we have to start the Kafka bridge. We use again the nodeps option with the up command. Alternatively, we may manually combine the compose files by removing duplicated services. Last, we deploy the worker data importer tool. Before issuing the up command, we are required to provide a JSON file containing the Google Service account credentials. Check out the GitHub repository for more details on this step. Now that we have all the containers up and running, we need to simulate data from sensors so that to see our tools in action. We start an additional container for sending random data to Orion. Also, we start a container to visualize data store in Orion through a web application. However, these tools are for this demo only and not released. If we open our Explorer application, we can see random data coming to Orion. We have to set up the connection to Orion first. Remember that Explorer and Orion are Docker containers. We can see entities of types biometrics and ergonomics. We have 3 entities for data from wearable devices, with physiological data, acquisition timestamp, and worker information. While for ergonomics data, we have 1 entity with the fraction of time a worker has assumed a certain position during the working shift. Now, let's create some intervention rules by using the IAM user interface. To add a new intervention, just click the Add button. We can edit the new added intervention by setting a short description and the command we would like to trigger. In this case, we'd like to suggest the worker to have a break. The rule must be triggered every time a dynamic parameter falls in a given range. In this case, we want to monitor the fatigue value in the range 5 to 8. But also, we want to check if the EAWS score falls in a given range by considering a fixed time window. By selecting the proper condition, we can set the parameter to monitor the range of interest, but also the aggregation function to apply to values collected in the given time window. We decide to monitor the average value over a 100 seconds time span. When satisfied with the rule, we confirm the intervention details by clicking on Save, and we go back to the intervention list. We add another intervention to make suggestion to a specific worker having special requirements. The command is the same as before, but now we change the rule conditions. We check if the EAWS score has a value greater than 100 and lower than 150. Then, we limit this intervention rule to a specific worker. The intervention is triggered only when the dynamic parameter comes from the worker identified by this UUID. If we go back to the Orion Explorer, we refresh the page to see the interventions sent to the broker. Interventions are now available to other components. For example, the SL tool will notify the interested workers with a push notification sent on a smartphone. Finally, let's see how to edit worker static data using the Worker Data Importer tool. The importer reads data from a Google spreadsheet with a scheduled job. The spreadsheet must contain all the parameters we can see here, with 1 worker per line. If multiple copies of the same worker are there, we assume the last entry as the most up-to-date. For users' convenience, a Google form can be created and linked to the spreadsheet, so that to ease and verify the data entry process. Here we can see the form generating the spreadsheet data we've seen before. The form may be personalized, even with custom fields, but the actual field names must be properly mapped in the importer configuration. To know more about how to customize the form fields and change the frequency of the importing job to fit your needs, check out the tool documentation. And that's all. We hope you'll find this video tutorial useful for deploying FAMS and IM in your scenario. More details are available in the tools documentation available online at GitHub. If you'd like to discuss more, feel free to get in touch with us. Remember to check out and subscribe the Better Factory YouTube channel to keep updated with tutorials related to other tools.